we're going to talk about for now is something that we call version control. Version control is a way for us to keep track of the different versions of software that we create. So, have you ever, most of you have written an essay at some point, right? Have you ever been writing an essay and then you accidentally trashed your essay by saving it at the wrong time or something like that? Who's had that happen before? Okay, like almost everybody, right? That kind of sucks, right? I mean, I assume you don't like it. Yes, sir.
I have a question. Are we supposed to be reading a chapter per week?
So the chapter, the assignments for the reading assignments are the ones posted. The question was, are we supposed to be doing reading assignments? And it's basically about a chapter a week, but all the reading assignments are posted on the Canvas page.
Okay.
So if you check there, they're all up there, okay? Like last week was chapter 3, and this week is chapters, I think it's 4 and 5, if I remember correctly. So, right, so it sucks to lose your work, right? That is what version control essentially does. Is every time we make a change to our software, and every time we commit that change, it allows us to keep track of things. So if we're doing a bunch of work, and we delete something, and later on we realize, I shouldn't have deleted that, or whatever, we can go back and pull that code back out. That's the power of version control, is that it's like a long-term undo button. That's probably the easiest way to explain it. So even if we get really far in our project, even if we're 2 weeks into the project, and like, oh man, I made a mistake, and I need some code from like 2 weeks ago, but it's not in my program anymore. You can go back to an old version of your program, and you can pull that code out. And source code files take up very little space. They don't take up much space on your hard drive at all. So it's very practical to keep a copy of every version of your code that's ever existed. Programmers are awesome, right? I assume you agree. And they're brilliant. You're all brilliant, right? Maybe. Maybe. Some of you? Okay. But they're also human. You are, in fact, a human being. And you make mistakes. And also, as much as we might like to pretend it's not the case, we must work with other human beings as well, right? Very few pieces of software are written by one person. We almost always work on a team of people. And that means that our mistakes get magnified and spread around. And we have to have a way to deal with that. Not only that, we have to have a way to bring our code together. And this is the function that version control serves. We must plan to fail. 90% of the work we do is mitigating failure. That's what it is. That's what the job is. That's what engineering and problem solving is in general. Version control is also called revision control and source control. But what it does is it protects us from our own stupidity, right? It protects us from the mistakes that we naturally make by virtue of human nature. And it lets us work faster, because if you can work without worrying that you might be messing something up, because you know you can... I can speak really well. I have the best words. You can tell I'm getting a little tired, right? We need to be able to work quickly. And sometimes being able to work quickly means that we need to have a system in place that will allow us to gracefully recover from mistakes. And that's the main function that version control serves. So there's a couple of different parts to version control, and I want to talk about each one of these. The first one is what we call a commit. And a commit is a change set. When we say something is a change set, we mean it is a set of changes between one version and another version. So let's say that I started writing my software, my Blackjack program, and I called it version 0, and it's version 0.1. That's what this is right here. And then I make some changes, and I make a commit. I have some changes that I've created a change set from. That's where version 0.2 comes from. So we move from one commit to the next by packaging up our changes and pushing them to the repository. We're going to get to the details of that in just a minute. But the basic idea here is that whenever we want to establish another version of our software, we're going to do a commit. We're going to create a commit, which means we are committing the changes we have made to a specific version of the software. Does that make sense so far? So each one of these little circles here on this graph is a commit. So there's one commit that takes us from point 1 to point 2, and there's another commit that takes us from point 2 to 1.0, and so on and so forth. Okay? Good so far? All right. So we also have what we call branches. And branches are different, well, they're different branches of the software, different versions, not just between point 1 and point 2, but we might have a stable branch, and that's what we give out to everybody else. And then we might have a development branch where we're creating new features. And we might have an experimental, also known as a bleeding edge branch, and we really do call it that in the industry sometimes, the bleeding edge branch, which is like the newest stuff that nobody's seen yet, and we're just playing around and trying new things. Also, sometimes we might make changes and they might be bug fixes. We might have our main stable branch, and there might be some error that causes a security issue, right? In that case, we would probably have a bug fix, right? So this is like these white ones are the bug fix branch. And sometimes we might have some kind of feature, and we're like, that's a really cool feature. I really wish it was available on the stable branch, and we might pull it in using a backport branch. Yes, sir?
Why do you go from point 1 to white and then it splits?
Oh, that's a good question. We're actually going to get to it in just a second. The question was, how come we go to the white one and then it splits? And the answer is what we call a merge operation, which we're going to talk about next. So can you hold that thought for a minute? Okay. It's when we bring two versions together, basically. So that is what we mean when we say branches. There's also the concept of a merge. A merge is when we take two different versions, sometimes they're in different branches, and we bring them together into something new. So in this case, like right here, what this line means is that our old version, point 1, that goes into point 2, but also, whatever was in the bug fix branch, that also went into point 2. So these two pieces come together, and they create a new change set in point 2. And that's a merge, when we bring two different lines of code, two different version lines together. There's a lot of different merges on this map. I pointed out 3 of them, but hopefully this is making sense. Does anybody have any questions? Yes, sir.
Okay, so where do you start and where do you end?
Good. The question was, where do you start and where do you end? So the answer is, it depends on what your goal is. So let's say that let's say I'm writing a piece of software, and let's take a browser. Firefox is a good example, right? They have a bunch of different branches, and they all started from some nugget somewhere, which is probably like point 1. It's either point 1 development or point 1 stable or something like that. So, but it usually starts on one side, right? And eventually, Firefox split off into 2 main branches. They have stable and development. Those are the 2 big ones. They have some other smaller ones, but those are the big ones. So what happens is, anytime they want to release a piece of software, anytime they want to release a new version of Firefox, and this is true of Chrome and a bunch of other browsers too, they take it from the stable branch. So usually the place that goes to the end user is from stable. And this is just one example. On the other hand, if I'm a developer and I'm doing bug testing, I'm probably not going to pull from stable. I'm probably going to try the development version. So which one is the endpoint really depends on who the audience is. Does that make sense?
Okay, so the blue dot always has a purple dot, pretty much? Nope.
It often has a purple dot, yes. And I think in most software models, yes, one development branch usually feeds into one stable branch.
Like, I'm trying to understand it by like columns, but I don't really.
Don't look at the columns. There's no columns. The columns don't line up with anything special.
Okay.
Does that make sense now?
Yeah.
Yes. Do you have a question?
So chronologically, we'd almost see like a zigzag, right? Starting from the development up to the stable, and back to development, and so on. Right?
I'm sorry. Say that again.
So if we're looking at it chronologically, we start development and move up to the stable, and then back down again, back up.
Yeah. So I mean, the question was, if we're looking at this chronologically, like how would it pan out? In this case, this example is supposed to be chronological, moving forward down the path. So if this was a piece of software, probably what happened is they had a stable branch, they copied it, they had a development branch, they copied it to stable, they only incorporated bug fixes into the stable. They kept developing the development branch, and then right about here, they were like, oh, we have these really cool features, let's push them into the stable branch. And that's where the backport comes in. Does that make sense?
Yeah.
So every software project is different. That's just one example. So this isn't like the one model to rule them all or anything like that. It's just there to give you an example to kind of hopefully conceptualize things. Yes, sir?
Okay, so you have those 2 green dots. That's like stuff that you're trying out, and then like, all right, we're going to try to implement it, and then it turns to blue
so
dots.
I'm going to repeat what you're saying as we go. So he said, these green dots down here, this is like experimental. We're trying some stuff out. Maybe it works, maybe it doesn't. Yeah.
Okay.
Yeah, exactly. And then like if it does work, then we're like, oh, cool, let's pull that into the development branch. In this particular example.
Oh.
So like I said, these branches aren't like something you have to have. Stable and development are pretty common in the industry, but there's no like hard and fast rule about it.
Okay, last question.
Yes, go ahead. Please, ask away.
Backport, what is that? Can you say that word?
Oh, the word backport. Okay, so first of all, so you don't have to know this for any quiz or exam. When we talk about a backport, we mean we take a version, we take some feature from a development version of software, and we push it into like an old stable version. So like basically it's, in this case, it's like we're taking a feature and we're porting it back to an old version.
Okay, updating an old version.
Does that make sense?
You're updating an old version.
Exactly. Yes, updating an old version. That's an easier way to say it. I should have just said that. Anyone else? Okay. So that is the idea of version control. One other thing we have is something we call tags. And tags are just there for human beings. So we're like, this version is special for some reason. In this case, we have tags for the releases. A lot of software development groups use the tag system for releases, but you can have other uses for them as well. It just means I'm giving a special name to a particular version, right? In this case, the tags I'm giving are for 0.1, 0.2, and 1.0, right? Okay. So that's the basic idea. One particular version control system is something called Git. How many of you have already had lab today? All right, oh, a lot of you. Okay, so you've probably seen your TAs talking about this a little bit. Git is what we call a distributed version control system. That means that everybody has a copy of every version of the software at all times. If you are connected to a Git repository, you have every version of the software that has come before, or at least the ones that have been made public. It may or may not have a central repository. Often, we're going to be using a central repository established by the company called GitHub. GitHub is a particular company that runs a software service where they let you store stuff on their servers. They happen to use the Git style or the Git format for repositories. But Git and GitHub are different things. GitHub is a company that offers a service. Git is a protocol. It's a way to create repositories. So it's an important distinction to be made between the service and the protocol or the format. The interesting thing about Git is, you may have heard of it. Does anybody know who made Git, by the way? Who made it?
Linus Torvalds.
Linus Torvalds. He's famous for this other thing you may have heard of called Linux, right? So Linus Torvalds created the Linux kernel, and then he got tired of the really crappy version control that he had access to, and so he created Git. And so that's where it all came from. Originally, there were no central repositories. They used to send each other change sets, commits, by email. And that's something you can totally do in Git and a lot of distributed version control systems is you can send them user to user if you want to. Now in practice these days, we usually have some service like GitHub. This little cloud here is like GitHub. We usually have a service like GitHub that we use, but you don't have to. You can transfer changes between one another if you wanted to. The commits are local, and those versions, those commits, the circles, right? They are local, and we have to push them to the server in order for other people to get them. What that means is we have to upload them, basically. When you talk about pushing versions, you're uploading them. You're giving them to somebody else. You're sending them to someone else. Everything is local on your machine. When you create a commit in Git, it's local until you push it, until you give it to everybody else. The rule of thumb is commit early and often. Whenever you make a change in your software, commit it. Create a new version. It's very inexpensive. It costs practically nothing. The resources are negligible. It will save you so much time. Every time you make any kind of major change to your project, commit it. And that way you can roll back. You can go back if you find a mistake, or if you need some code that you accidentally deleted, or whatever. So that's the idea behind Git. But it might make more sense if we actually go through a demonstration. So that's what I'm going to do next, is I'm actually going to walk you through actually using Git. Some advanced notice, you're going to need a couple of things. I recommend, you can use whatever you want, but I recommend, and we will support, SourceTree, which is a GUI application that is available both on Mac and on Windows. So please download it, and please install it unless you want to be on your own, which is also okay. But just know that this is the one we're going to support. You're also going to need to have access to a command line version of Git. If you're on Windows 10, I highly recommend the Windows Subsystem for Linux, which is basically running Ubuntu stuff on Windows. It's pretty cool. If you have questions about it, let me know. But there's a link here to the installation process. If you are on Windows 7 or 8, then MSys2 is my recommended platform for command line Git stuff. If you are on Vista or XP, what is wrong with you, and why have you not upgraded? Also, you're a terrible security breach, and stop it. Yes, sir?
Okay, so for these, be on
the question is, are these links going to be on Canvas? And the answer is they're all on the lecture slides, which are already on Canvas. Yes. So yes, these links are all on Canvas. If you are in Mac OS, it already works. Congratulations. At least the new versions of Mac OS. If you're on an old version of Mac OS, what is wrong with you, and upgrade. So anyway, so this is what you're going to need. You don't have to have it right now. I'm going to use the system that I already have installed, which is Windows 10 with the Windows Subsystem for Linux. And I'm going to go through the GUI stuff to start. We'll probably, if we have time, I'll show you some of the command line stuff. But I want to start with the stuff that's on the GUI. Okay, so let's open up SourceTree. Where did it go? Oh, I see it. Ah, there it is. The icon changed. That's where I was confused. All right, so this is SourceTree. This is what it looks like. And I'm going to take you through an example on a test repo. Actually, no, I'm going to show you an example of a real repo. This is a project that I've been working on. And these are a bunch of commits, a bunch of different versions, a bunch of different changes that I have committed. If you look, there's some older versions that were made by some other people. And you can kind of see the pattern that you saw on the slide before, where things branch off and then they reconnect, they merge, right? So here's a merge point where these two versions came together. Sometimes we have different versions happening at the same time. Two people are working separately, and then maybe later, like up here, they might bring them together at some point, right? So they might be working separately, and then you bring the code together and you make sure it works. So further up here, you can see that I've been making some changes to this project, adding code, subtracting code. The neat thing about SourceTree is that when you actually, this is in case you can't tell, this is a Ms. Pac-Man emulation layer. So, which I'm going to try and make into a project for this class. We'll see if I can make it work. But that's my goal. But if you look at an example here, for example, you can see it'll show you the code, and in green it'll show you the changes that have been added. So if I keep scrolling down, it'll show you all the places I've added code in green. And any place I've taken away code, it'll show it in red. So it's actually showing me what changes have been made to each source file with each version, which is a pretty neat feature because you can figure out when a change occurred to a particular source file this way. Now, if I was ready to create it, this is just a configuration file for the window, right? So I'm not actually going to, you know what, actually I am going to create this. So let's say I have some change. In this case, it's the configuration file for my IntelliJ window. When I'm ready to commit a file, I do what's called staging it. And staging the file says, I'm ready to create a version with this file. Once I've picked everything I want to stage, then I can hit the commit button. And the commit basically is how we create a new version. And I might say, changed configuration files. Right, or I'll spell it here. Changed configuration files, right? Or something like that. And then, so that's my commit message. That's just a description of what this version changes. And then I click the commit button. And if I go back here, I can now see that my new version is added, right? So this was the previous version. This is the new version. Make sense so far? Okay. Now, if I want to make it so that this goes up to the main server, to the GitHub server, we're going to talk a little bit more about GitHub in a minute, then I would hit the push button. That's what push is. If there are changes on the GitHub server that I want to grab from remote, like say some of my friends were working on this project and I wanted to get the code that they had committed, I would hit pull, right? So pull, push. Push is to push your changes up. Pull is to grab the changes of other people and bring them down, right? So for this first project, I do recommend you use GitHub. No, we won't be checking to make sure that you're doing it. It's totally up to you. We will create a repository. We do require you to be able to use it. So there will be a lab focused on this stuff so that you guys can learn and play around with things. However, we're not going to micromanage you. It is up to you. It is your responsibility to keep track of this stuff. But please, please, I'm begging you, pretty please with the cherry on top, please use version control. Please, you will regret it if you don't. You may not regret it on this project, but you will regret it soon. I don't know when. It's unpredictable. But I can't tell you the number of times that I personally have lost code because I thought, I don't need to put this in version control. It's a mistake. It's always a mistake. Every time I've done it was a mistake. Put it in version control. It costs you practically nothing. There's a learning curve, but you're going to have to learn this stuff for the industry. You're going to need to know it. So it's worth putting in the time now. Okay, so this is an example of a test repository that I just made the other day. And this repository is connected to GitHub. So I'm going to go ahead and bring up GitHub so that you guys can see how this works. Now, this is an important fact. GitHub is totally free for you. It also gives you a free student repo, and there's some other goodies that GitHub will send you, I believe, for free. I don't remember exactly what it is. I know that they send me stuff for the class for free, so I'll have like t-shirts and posters and stuff I can give away later. So if you're interested, let me know. But, you know, I don't know who wants like a GitHub poster. But if you want it, you know, I'll get one for you. Just let me know. Yeah, it's probably not the type of thing you pin up on. Second thing I pin up on. Anyway, so do sign up. I want you, unless you have some moral objection to signing up for a GitHub student account, you should sign up for one. We're going to require you to sign up for one unless you have a moral objection like to their standards of use, which I can't imagine you would, but if you do have some kind of objection, then you're going to have to let us know, and then we'll create some replacement assignment or something. But otherwise, I heavily recommend you do it. So we're going to expect you to create one unless you fall into that category, and we're going to expect you to at least learn how to use it at a minimum. I'm going to go ahead and open up GitHub in our last few minutes here and try and show you an example of how we can work between the web platform and our local code base. So, let's see. All of your, you may already there's every student, sorry, some people's names are going to be up here. Every student's going to have a repo, okay? And these are all TAs, so I can show them. That's good. There is a, let's see, is it called test repo? Is that what it's called? Do you remember? I'm going to say it's called test repo. No, it's not. Let's see. Did I miss one? Here it is. All right. So when you log into GitHub, any repos you have access to, they're going to show up. Okay, so this is my example repo. You can see it has an example txt file. If I wanted to, I can easily add a README file. So that's what I'm going to do now. And right here, I can say, this is my README file. Okay, this is my README file. Okay, and then I have to have a commit message, which the default is create README, so I'm just going to go with that. Okay, after I've committed that on the web portal, if I go back over to SourceTree and I take a look, then I think it's just right now it's looking. But if I hit this pull button, then it should pull down the change that we just made. Yep, and there it is. So you can see that create README has been added here. Likewise, if I go to my folder, let's see. If I go to my folder where this is held, where this repo is held. Okay, you can see the files there, right? But let's say I wanted to add another file here. I could do, let's say I just wanted to make a copy of this. I'll call it example 2. Right? And if I go back over to my source tree window, and I give it a second to load, it's taking a minute. Basically what's going to happen is there it is. The new file is going to be listed in uncommitted changes. Just like before, I can stage it, I can commit it, added another example, and then I can commit it, and then I can push it. Now, if I go back over to GitHub, and I reload, now that other example file is showing up, right? So basically, this is a way for us to go back and forth. Yes, sir?
So this is not important until the second project?
I would say that I'm never going to require you to do something in micromanaging. I would recommend you start with the first project, though. My recommendation is start using it right away.
Okay.
But no, I'm not ever going to check to make sure you're using it. You are going to have to, the next lab next week is going to require you to be able to use this stuff. So it will be required for the lab, but it won't be required for the projects. Does that answer your question? All right, anyone else have questions at this time? All right, so that's GitHub. If you do have questions about Git or GitHub, please feel free to email me or ask me. Your TAs do know something about it, although they haven't been in the industry quite as long as I have, so they may not know quite all the little bits and pieces. But do feel free to ask anytime. Okay, so with that said, the last subject I want to start touching on for our last 20 minutes here is functions and methods. So we've seen a little bit of methods up to this point. We're going to start digging into that in a little bit more depth. So if you're following along, this is lecture slide set 6. The idea of a function or method, also called a procedure, is that we want to package out a section of code and give it a name of some kind. So up to now, the method we've been using the most is called main. That's the entry point for a program. So that's our main focus at the moment. But we can actually create other methods, other packages of code, other functions that will allow us to do things over and over again separately. So in computer science, when we talk about a function, we're talking about a named block of instructions. And if it's part of a class, which everything in Java is part of a class, then it's a method. So you're going to hear, in this class, you're going to hear function and method used interchangeably, because in Java they are basically the same thing. Every method in Java is a function. I'm sorry, every function in Java is a method. when you start looking at some other languages later on, when you guys get to C++, there will be functions that are not methods, but for now, they're kind of interchangeable. Whenever we run a function, whenever we invoke it, that is what we call a function call or a method call, depending on how we're referencing it. So let's say I had a class called Remagerd, and I wanted to have a special block of code, and all it does is say, hello, I'm Batman. I might make a function, a public static void, say hello function in this case, and we will eventually get to what these other identifiers mean, but we're not there yet. And it'll just have one line, system.out.println, hello, I'm Batman. Then, in my main method, instead of having the code directly there, I could just call the function, say hello. So this is how we start to create blocks of code that we can reuse. So this is a very simple example of a very simple function. We take a block of code, we give it its own name, and then instead of copying and pasting those instructions every single time we want to use them, we just have to use the name. And then all the code inside of that block can get executed. Make sense so far? Okay. Any questions up to this point? Yes, and then you're next. Yes.
Actually, never mind.
Okay. Well, if you still have a question later, make sure you ask.
It goes back and runs everything that's in say hello, right?
Right. That's a good question. So I'm going to rephrase what you said, but I think I should point this out to everybody. So another way you can think about it is that once we get to main, when it sees say hello, it's going to jump up here and it's going to execute all the instructions into here before it goes back. So that's a good way of thinking about it. But that is exactly what happens. Did you have a question? Yeah. Question was, can you use it in your project? And the answer is absolutely. If you want to use it in your project, you are welcome to do so. You're not required to do so, but you are definitely welcome to do so. Does that answer your question? All right. Did somebody else? I thought I saw another hand up here somewhere. Maybe not. Maybe I'm blind. Okay. So that's basically how functions and methods work. Functions and methods that we've used up to this point a lot, they usually have parameters. And those parameters allow us to say, here's some information you have to pass into this function every single time you run it. We call the values that we pass in arguments. So in this example, here's another example. I changed our function say hello so that it takes in a string. It takes in a string called name, and then it's going to print out hello, I'm, and whatever the name is. Right? So the parameter is name in this case. We've created a parameter name, and that function is based on the parameter now. This time, when we go ahead and run it from main, instead of saying just say hello with nothing inside of it, we're going to pass in an argument, Batman. And now, when it prints out that string, it will say hello, I'm, and then in this case we passed in Batman, so it's going to say hello, I'm Batman. Right? It's a different way to get the same result. But I could also put say hello, Bob, and then it would say hello, I'm Bob. Right? Make sense so far? Okay. Yes?
How does the code know what name is?
Good question. So the question was, how does the code know what name is? And the reason is because right up here we told it that we're going to get a parameter name. So we said, you have to give me some info. Yeah. Does that make sense now? Yes.
In a sense, it's kind of like a variable.
Yes, that's exactly what it is. So he said, in a sense, it's kind of like variable, and actually, that's exactly what it is. It is a variable. It's a parameter variable, is actually what we call it. So you're absolutely correct. It is a variable. Does that make sense? All right. Anyone else? Yes?
You have to put string name, or can you initialize it by higher option code and then just put name?
That's a good question. The question was, do we have to put string name, or could we initialize it higher up in the code? And the answer is, if we want it to pass in, we have to define what it is right here. We have to define it here if it's going to be a parameter. So if it's not going to be a parameter, we have other options. But as long as it's going to be, a parameter, I'm so clumsy, unbelievable. As long as it's going to be a parameter, you have to say the type inside the definition itself. Make sense? Okay. Anyone? Yes.
So what if, like, rather than just string 1 and integer, you put like a number there?
Oh, that's a great question. The question was, what if instead of string, could I put like an integer in here? And yes, you absolutely can. You can put any type in here. I just happen to use string in this case because it made the example easy. But you could use any type of variable in there. Good? Yes.
I thought the static or the void meant that they don't return anything.
What's that?
I thought the word static or and void or they don't return anything, and then
Right. So the question was, I thought void doesn't return anything, and the answer is it doesn't. It's not actually returning anything back to this main function. It's printing it out to the screen. So there's a difference. There's a distinction between sending a value back into the previous part of the program. That's a return, and printing something out to the screen. So this is printing it out to the screen. It's not storing it in memory. Yes.
So how would you do, like, say like your program did like whatever value you put in squared, how would you get that the output out?
The question was, if you had a function that wanted to do a square, like square a value,
Like any
yeah,
function.
or do some kind of mathematical operation.
Yeah, like
how do you get it out? It's a great question. We're about to get to that. So yes, you can have what we call return values, and we're going to talk about that next. Yes, sir.
It was actually a comment. It seems like everybody has a flu today, or it's just me.
Yeah, I'm losing my voice because I've been talking for almost 2 hours now. But
Right.
yeah.
I mean, because everybody's coughing. I don't know why.
Let's see. Any other questions before we? Yes.
Oh, no, let me forget it.
Line 8 was string article. Has that parameter?
Oh, that's a great question. Somebody said on line 8, is this string args, is that a parameter? And the answer is yes, it absolutely is. That's exactly what it is. This is the parameter. So you've probably seen people, you can type stuff on the command line. Like, how many of you guys have ever used the command line? Okay, most of you. So anything you type after the command name itself, those are the arguments for that command. Those in Java, those go in here. This is where they get stored. So we can actually have a Java program that takes input from the outside world, and that information gets stored here. So we haven't gotten into the details of that, but that's how it works. Does that answer your question? Okay, anyone else? Okay, so that's the basic idea behind functions. We can also have more than one parameter. We don't have to have just one parameter. We could have more than one. Like maybe we want to split it up into first and last name. In that case, I just have to list all the variables and put commas between them, right? All the parameters and put commas between them. And then, when I call it, I have to make sure that I put the different, values that I want to pass in right here. In this case, it's going to say, oh, I'm Batman, 2 words, right? Because I put first name and last name separately. So, somebody said, what if I wanted to get information out of the function? What if I didn't just want to print stuff to the screen? And that's where return values come in. The way that return values work is that we're going to pass information back to whatever line of code invoked this function or method, whatever line of code executed this function. So, let's say that instead of printing something to the screen, we wanted to get a greeting string. So, we're going to have a public static string get greeting. What that means is that it is going to give us back a string. It's going to pass back a string. So let's see what this might look like. I might pass back the string, hello, I'm first name, last name. And that's going to create a string from the parameters and send it back to wherever we called this function from. So, right here in main, maybe we say, we have a variable greeting. We say greeting equals get greeting bat man. So we go back up here, and it's bat and man, and it's going to return a new string, hello, I'm Batman. That is going to go into the greeting variable when we execute this line. Once it goes into the greeting variable, then we can print out the greeting variable, and it'll print it to the screen. So this is how we actually get information out of a function or method call. Yes, sir?
Could you also print a function method if you put the arguments?
Oh yeah, the question was, could you print a function argument if you could you print a function from a function call if you put in the arguments? And the answer is yes. I could actually have skipped a step, and instead of putting greeting here, I could have put get greeting Batman in here. Does that answer your question? That would have been a good shorthand in this case. All right, anyone else? Any questions? All right, I can see everybody's getting pretty tired. So let me just close out with this one last slide, and I'll let you guys get out of here a little early today. So why do we bother with this? Hopefully you're already seeing some reasons why we might want to use methods, but there are a couple of main reasons. Our code needs to be readable. It's way easier to read code when the stuff that we have repeated over and over again is in a tiny little bite-sized name instead of a giant list of instructions. Rather than copying and pasting stuff, just being able to put that name makes it way easier to read. It also makes it more modular. It means we can reuse the code a lot, right? And we can break it up into pieces that are manageable. It also helps with abstraction and with chunking and breaking things into pieces. So this is going to be a pretty common approach. If you have any questions, please let me know. I will stick around. Thanks for coming. I'll see you Thursday.